today we are on the second section of chapter 3. We're going to talk about logarithmic functions. They're the inverses of exponentials. That's why we kicked off the chapter, of course, with exponential. I'm going to show you how to convert those into log form today. But first, do a little warm up here with our exponent properties again. Make sure you catch those directions. Answers should only have exponents. So x to the negative fifth in the denominator. So we're just going to move it up to the numerator. That allows you to change the sign on the power. Clearly, you don't have to keep the 1 in front. I would just put x to the fifth, of course. All right, b, same problem. You have that negative exponent. So if I want to change negative 3 to a positive 3, I have to reverse my fraction. Then I'm just going to calculate that. 2 over 1 is 2. 2 to the third power, 8. Okay, multiplying. Let's first add these up and see what that totals out to be. Negative 4 plus 6, 2. No negative exponent to deal with, so we are done. Let's get into logarithms. So today we're going to talk about how to convert between the two forms versus exponential form with the exponent, how to convert that into logarithmic form. So of course, whatever is raised to the power, we're going to call that the base. So that goes on the kind of a subscript by log. And then your x and y, notice y is on the left, it's going to move to the right. And vice versa. They're going to switch directions. So you're equaling out to your exponent. It's really an exponential problem. So write the logarithmic equation in exponential form, and they even give you a little example in the directions. That's so very nice of them. Here we go. I always start with the base. So in this case, raised to the opposite side equals the expression after the log 1 is referred to as the argument in mathematics. That's our fancy word for it. And of course, your equation should always be true. Yes, 3 to the 4th power is equal 81. So I know I have everything in the correct location. All right, B. Same thing. I'm going to start with the base, 10, raised to the opposite side equals my argument, the expression after the log. And yes, that is a true equation. So you can always check if you have the right thing, if everything's arranged right. You should always have a true equation. Starting with the base, raised to the opposite side equals our argument. Now, you can test this in your calculator. You can type in 16 raised to the 3/4 power. It will give you 8. So you can always test it to make sure you have everything arranged correctly. So now we're doing the opposite. We are in exponential form. We're going to convert to logarithm form. So I'm going to start with the word log. Now, first thing I look for is the base. The base is what has the exponent on it. So in this case, our base is 8. 2 and 64 are going to change sides of the equation. Because remember, a log is the inverse or opposite of an exponential. So that is why we're switching sides on our equation. All right, let's do letter B. Again, I'm going to start with the word log. So first thing, I'm going to identify the base. It has the exponent on it. And then 27 and 3/2 are going to flip sides of the equal. Simple enough. You got to just know where to arrange everything. Not very much work today. You just have to be able to arrange it all. All right. Don't let the variables throw you off. Same process. Our base is going to be n this time. T and 10 are going to switch sides of the equal sign. Looks kind of goofy with the variables, but same process. Okay. So some simple different properties of logarithms that we're going to see coming up throughout this chapter. Let's just kind of take a look at them quickly here. Log base a of 1 equals 0 because 0 is the power to which a must be raised to obtain 1. Meaning, that's awfully wordy, if you write this in exponential, the base to the opposite side. So really the power is 0, your exponent 0, anything to the 0 power, of course, 1. Okay, second property. If you have a log with the same base as the argument, they are going to cancel out to the exponent, which in this case is 1, but it's clearly, of course, defined as 1. Same property for 3. It's the same idea. Your base and argument are the same. They're going to cancel out and equal your exponent because x is the power to which a must be raised to obtain a. So many variables. This one's nice and easy. If you have a log with the same base, on either side, they cancel each other out. So x is going to equal 1. Simple enough. Okay, so natural logarithms. We have seen the e come up in that first section on our calculator, second ln. Today we're going to talk about how to write that in a logarithmic form. Log base e, we never leave it log base e, we write it as the natural log ln of x. So those same properties we just went through hold true for natural logs. Any property of a log also is true for a natural log. So ln of 1, 0. Because of course, remember, that's really e. E to the 0 is the power to which e must be raised to obtain 1. Ln of e, ln of e, same thing. Remember, ln is your really log base e, so they're going to cancel out to your exponent because 1 is the power to which e must be raised to obtain e. E to the first is e. Ln and e, of course, are going to cancel each other out, leave you with the exponent, because x is the power to which e must be raised to obtain e to the x. And same thing as the last property. If you have a natural log on either side, they're going to cancel each other out. So these are the same four properties we just went through. They're just in a natural log style. Okay. Evaluate the function at the indicated value of x without using your calculator. So we're supposed to do these, of course, by hand. So the first thing I'm going to do is replace x with that 1/4. Okay. So next up, let's take a look and try to get these all written in the same base. Meaning, you really have to have kind of a number sense here. 16 are related to one another. Now we want to try to rewrite it with our same base. So I want to keep the 16 in here. So I know that square root of 16 is equivalent to 4. I like the 16s. I'd like to take this out of a fraction and a radical style, of course. A lot of algebra 2 skills here. So the square root of 16 is really an exponent. 1/2 for an exponent. And then again, I want to get it just 16, not 1/16. So I'm going to make that, I'm going to move the 16 to the half above, which then I have to change the sign on the power. So all this little tricky number work, just so I can get me down to the property, log base 16 and the argument are the same, so they cancel out, -1/2. So the log work is trying to get the key here, the base and the argument in the same number. We just had to use a lot of algebraic skills to make that happen. Are they all that tricky? No, but you might have one or two on the homework. All right, same process. First, I'm going to read 100,000. Now, same thing. I want to try to write the base the same power, same number. So you have to have a little number sense to you. So I'm trying to figure out 100,000 is 10 to what power? Now, I know it says without a calculator, but you might need your calculator to figure that part out. 10 to the 5th power is equivalent to 100,000. Now, my base, my arguments are the same. They're going to cancel out, leave you with the exponent of 5. I don't think that one was as tricky as A was. Okay, let's take a look at these guys. Use your calculator. Use your calculator. So I'm going to pull up, of course, my calculator here. So let's open it up. You probably know where all of this stuff, of course, is. Come on. So again, you know where probably most of these keys are on your calculator. I'm just going to minimize my screen here quick and pull it up just to show you. Of course, log key over here on the left side right next to number 7. I'm looking at this guy right there. That's what we're going to be using. You can see underneath it, of course, our ln. So I'm literally typing these in. On your calculator, it just says the word log. It's implied to be in base 10. So both of these I can just punch in my calculator. I'm going to hit the log key and then 4/5. All right, let me pull up the calculator just to show you. I'm going to hit my log key and then 4 divided by 5. You can close up the parenthesis. It won't affect it if you do not. I'm just going to go ahead and enter. And then, of course, we're going to round to 3 decimal places. So I'm going to put -0.097. Gotta love these. Nobody gets these wrong. Okay, same thing. Log base 10 is my log key on the calculator, so I'm going to type that in just as it appears. Now we've got the 1.9 log key, and then let's hit 4.3. Enter. And we're going to round, of course, to 3 decimal places, so I'm going to put 1.204. Got it. Okay. All right, moving on. So solve the following equations for x. So we are using those 4 properties we went through at the beginning with just the logs and then just with the ln's. So If you have, of course, log base 5 on either side, they're going to cancel each other out, so x equals 5. You can put 5 equals x. I like the variable first. Okay, B, your base 6 and your argument are the same. So they cancel each other out, leave you with the exponent. Of course, I'm going to flip it, x equals 2. I just like the variable first. All right. C, same type of thing as A, log with the same base on either side. They're going to cancel each other out. 4 squared, let's just calculate that in our head. Let's put 16 for 4 squared. Nothing too shabby there. All right, more properties. So this time we're in exponential form, but your base are the same. So they're going to cancel each other out. So we're left with 36x. And then same idea here. We've got the 1/4. We have to do a little bit of work because we need the base and our argument in the same value. So of course 16 is the same as 4 squared. So now my base argument the same. They're going to cancel out. Now the operation really between the 1/4 and the log, remember, is product. So I'm going to do 1/4 times what's left for my exponent 2. Of course, a quarter times 2, 2 quarters, 1/2. Got it. Okay, not too shabby, not a lot of work today. Make sure you know your properties. Enjoy your homework. Have a great day.